Ever seen a robot almost drown in bubbles? Welcome to the Tiny Inventors workshop where science solves even the silliest problems. It looks like something interesting is happening today. Sami seems way too excited, and that is never a good sign. Ta-da! Behold the Super Bubble-tastic Ultra Machine 3000. Wow, Sami, that's big. Does it even work? There's only one way to find out. Oh no, Sami, turn it off. I can't. The switch is stuck. It looks like a bubble disaster has officially begun. When bubbles take over your lab, you have to think like a scientist. Okay, team, let's calm down and think. How do bubbles even form in the first place? I know this. Bubbles are made of soap and water. They trap air inside, right? Exactly, Mia. So, the soap and water mixture is a liquid, and the air it traps inside is a gas. When the liquid film surrounds the gas, it creates that stretchy, wobbly layer we call a bubble. So, if we want to understand how to stop this bubble storm, we first need to understand the science behind it. Think of it like a tiny, floating balloon. The outer skin is the soapy water, and the air inside is pushing outwards, trying to escape. This push is what gives a bubble its shape and makes it float around. It's a delicate balance between the liquid holding together and the gas pushing out. And right now, Sami's machine is creating way too many of them. Yeah, but why are all the bubbles round? Why aren't there any square bubbles or triangle bubbles? I love triangles. That's a great question, Sami. It's all about physics and energy. A sphere is the most efficient and strongest shape in nature. It uses the least amount of surface area to hold the most volume inside. So, the bubble naturally pulls itself into a round shape because that is the form where it has to do the least amount of work to hold the air in. It's the laziest and strongest shape it can be, which helps it stay stable and not pop so easily. If you tried to make a square bubble, the corners would be weak points, and the surface tension would pull them inwards, rounding it out almost instantly. Nature loves efficiency, and the sphere is its favorite shape for that reason. Okay, so we know bubbles are a liquid film trapping a gas, and they're round to be strong and save energy. How does that help us stop this bubble catastrophe? Well, if a bubble needs trapped air, that means Sami's machine is using some kind of air pressure to force air into the soapy water. The machine must have an air pump. Yes, if we stop the air pump, we stop the bubbles. We need to disconnect the air supply. I'm on it. I can reroute the wires. Got it. Disconnecting the main air tube now. Great job, team. We did it. And we learned so much about the science of bubbles along the way. I call this a bubbly success. So, what did we learn today? First, bubbles are made of a thin film of liquid, like soapy water, that traps a gas, like air, inside. Second, the water is a liquid and the air is a gas, and it's the combination of these two states of matter that makes a bubble possible. Third, bubbles are always round because a sphere is the most energy-efficient shape, allowing them to be as strong as possible with the least amount of effort. And finally, and most importantly, we learned that teamwork and a little bit of science can solve any problem, no matter how big or bubbly it gets. Oops, looks like there's a bonus bubble. Thanks for joining us at the Tiny Inventors workshop. If you had fun learning about the science of bubbles with us, don't forget to hit that like button, share this video with a friend, and subscribe for more awesome science adventures. We have new inventions and experiments coming your way very soon. Stay curious.